The 7 most scariest truths about the universe. Hey there, and welcome back to our channel. If you're new here, we're excited to have you join us as we explore the 7 most scariest truths about the universe. Whether you're a seasoned science enthusiast or just curious about the world around us, our videos are designed to inform, entertain, and inspire you to learn more. So sit back, relax, and let's dive into the fascinating world of science together. However, before we continue, take a moment to like this video and subscribe to my channel. Without much ado, let's dive in. 1. The universe is expanding at an accelerating rate, and we have no idea why. The discovery that the universe is expanding at an accelerating rate is one of the most profound discoveries of modern cosmology. The idea that the universe is expanding is not new. The expansion of the universe was first proposed by Belgian astronomer Georges Lemaître in 1927 and later confirmed by the observations of American astronomer Edwin Hubble in 1929. Hubble found that the galaxies in the universe were moving away from each other, and that the farther away a galaxy was, the faster it was moving. However, in the late 1990s, 2 teams of astrophysicists studying distant supernova made a surprising discovery. They found that the rate of expansion of the universe is not slowing down, as one might expect due to the gravitational attraction between galaxies, but rather, it is accelerating. This discovery was so unexpected that it earned the Nobel Prize in Physics in 2011. So why is the universe expanding at an accelerating rate? The short answer is that we don't know for sure. However, scientists have proposed a few possible explanations. One possibility is that there is some unknown form of energy, called dark energy, that is causing acceleration. Dark energy is a hypothetical form of energy that permeates all of space and has negative pressure. This negative pressure could be causing the universe to expand at an accelerating rate. However, the nature of dark energy is still a mystery, and we do not know what it is made of or how it works. Another possibility is that our understanding of gravity is incomplete. Einstein's theory of general relativity is the best description of gravity we have, but it may not be complete. There may be some modifications to the theory that would explain the acceleration of the universe. 2. Supermassive black holes at the center of most galaxies can rip apart stars and devour entire solar systems. Supermassive black holes are incredibly dense objects located at the center of most galaxies, including our Milky Way galaxy. These black holes are called supermassive because they can have millions or even billions of times the mass of our Sun. One of the most fascinating and scary aspects of supermassive black holes is their immense gravitational pull. The gravitational force of a supermassive black hole is so strong that it can pull in stars and gas clouds that come too close to it. As these objects get closer to the black hole, they are stretched and compressed by strong gravitational forces until they eventually cross the event horizon, which is the point of no return beyond which nothing can escape the black hole's gravity. When a star gets too close to a supermassive black hole, the intense gravitational forces can cause the star to be torn apart. This process is called spaghettification because the star gets stretched out into long, thin strands like spaghetti. As the star is torn apart, its material is pulled toward the black hole and forms an accretion disk around it. The material in the accretion disk heats up to millions of degrees and emits intense radiation, making it visible to telescopes as a bright source of X-rays. In addition to tearing apart stars, supermassive black holes can also devour entire solar systems. If a solar system gets too close to a supermassive black hole, the gravitational pull can destabilize the orbits of the planets and asteroids, causing them to collide and merge. The resulting debris can then be pulled toward the black hole and form an accretion disk. The supermassive black hole at the center of our Milky Way galaxy, for example, is about 26,000 light-years away from us and poses no direct threat to our solar system. However, studying the behavior of supermassive black holes is important for understanding the evolution of galaxies and the universe as a whole. 3. Our solar system is constantly bombarded by cosmic radiation, which can cause mutations in DNA and potentially lead to cancer and other diseases. Cosmic radiation is a type of radiation that comes from outside of our solar system, mainly from high-energy particles, such as protons and atomic nuclei that are produced by supernova explosions and other violent events in the universe. When these particles collide with the Earth's atmosphere, they create a cascade of secondary particles. including neutrons, moons, and electrons, that can penetrate the Earth's surface and into buildings, planes, and spacecraft. In space, where there is no atmosphere to shield against cosmic radiation, astronauts and space travelers are exposed to much higher levels of radiation than they are on Earth. The human body is not designed to withstand high levels of radiation, and exposure to cosmic radiation can cause damage to DNA and other cellular structures, leading to mutations and potentially cancer and other diseases. The risk of radiation-induced cancer and other health effects depends on the amount and duration of exposure, as well as the type of radiation. To protect astronauts and spacecraft from cosmic radiation, NASA and other space agencies use a variety of shielding techniques and materials, such as water, polyethylene, and other plastics, to block the incoming radiation. However, even with shielding, there is still a risk of exposure to cosmic radiation, particularly during long-duration space missions. In addition to protecting astronauts, studying the effects of cosmic radiation on living organisms is also important for understanding the potential impact of radiation on life in space and other planets. 4. Asteroids and comets in our solar system have the potential to collide with Earth and cause massive destruction. While most asteroids and comets pose no immediate threat to Earth, some of them have orbits that bring them close to our planet. These objects are leftovers from the formation of the solar system, and if one of these objects were to collide with Earth, it could cause massive destruction and loss of life, depending on its size and impact velocity. The impact of an asteroid or comet can release enormous amounts of energy, equivalent to many times the energy of the largest nuclear bombs. The resulting explosion can cause shockwaves that travel through the Earth's surface, triggering earthquakes and tsunamis. The impact can also send large amounts of dust and debris into the atmosphere, blocking sunlight and causing a global cooling effect that could last for years. Fortunately, the chances of a catastrophic impact are relatively low, as most large objects in our solar system have been identified and their orbits are well known. NASA and other space agencies track these objects using ground-based telescopes and space-based observatories, and they work to identify potentially hazardous objects that could collide with Earth. If an asteroid or comet were identified as a potential threat to Earth, there are several options for mitigating the impact. One option is to deflect the object using a spacecraft, which could nudge the object off its collision course. Another option is to destroy the object using a nuclear weapon or other means, although this could create a shower of smaller fragments that could still pose a hazard to Earth. 5. Mysterious dark matter and dark energy make up 95% of the total mass energy content of the universe, and we have no idea what they are. Dark matter and dark energy, collectively known as the dark sector, comprise about 95% of the total mass energy content of the universe. Dark matter is invisible to telescopes and other astronomical instruments, but its gravitational effects on visible matter, such as stars and galaxies, suggest that it plays a crucial role in the formation and evolution of structures in the universe. Despite extensive research, the nature of dark matter remains a mystery. It is not composed of any known particles, and its properties are not well understood. Some theories propose that it is composed of new, undiscovered particles, or a manifestation of the effects of gravity on larger scale. On the other hand, dark energy is causing the universe to expand at an accelerating rate, contrary to expectations that the expansion would slow down due to the gravitational pull of matter. The nature of dark energy is also not well understood, and some theories propose that it is a property of space or related to a new, unknown force in the universe. The discovery of dark energy was unexpected and has revolutionized our understanding of the universe. Understanding the nature of dark matter and dark energy is one of the biggest challenges in modern astrophysics. Scientists are using a variety of methods to study them, including observations of cosmic microwave background radiation, the large-scale structure of the universe, and the motions of galaxies and stars. Further research is needed to unlock the mysteries of the dark sector and advance our understanding of the universe. 6. Cosmic phenomena like gamma-ray bursts, supernova explosions, and coronal mass ejections can cause mass extinctions on Earth. Cosmic phenomena such as gamma-ray bursts, supernova explosions, and coronal mass ejections can cause mass extinctions on Earth. Despite their rare occurrence, their impact on the cosmos can have a great effect on life on our planet. Gamma-ray bursts, for instance, are extremely energetic events that happen when a massive star collapses into a black hole or neutron star, emitting gamma-ray radiation that could damage the ozone layer and alter DNA. Supernova explosions, on the other hand, are catastrophic collapses of dying stars that emit vast amounts of radiation, which could affect the Earth's climate and atmosphere if it occurs in our galactic neighborhood. Coronal mass ejections from the Sun's corona can disrupt Earth's magnetic field and cause widespread power outages and communication system disruptions. 7. The ultimate fate of the universe is one of heat death, where all matter is spread out so thinly that the universe becomes a cold, dark, and lifeless void. The ultimate fate of the universe, according to the second law of thermodynamics, is heat death. This occurs as the universe continues to expand, and all matter becomes more spread out, eventually leading to a state of maximum entropy where there is no more energy transfer possible. In this state, the universe will be a cold, dark, and lifeless void with no more stars, planets, or life. It is estimated that this will occur in approximately 10⁻100 years, an incredibly long time in human terms. While the prospect of a cold, dark, and lifeless universe may seem depressing, it is important to remember that we still have billions of years before this eventuality occurs, and who knows what discoveries and advances in science and technology may occur before then. The ultimate fate of the universe is a reminder of the impermanence of all things and the need to make the most of the time we have. However, it's important to remember that this is an incredibly long time in human terms, and there is still much to be discovered and achieved before then. In conclusion, cosmic phenomena like gamma-ray bursts, supernova explosions, and coronal mass ejections can potentially cause mass extinctions on Earth. While these events are rare, they are still a possibility that scientists and researchers take seriously to understand their nature and effects and to protect life on our planet. Thank you for watching. If you enjoyed this video and want to see more content like this, be sure to subscribe to our channel and hit the notification bell to be notified of new uploads. Don't forget to like and comment on this video to let us know your thoughts and suggestions for future content. And as always, stay curious.